So today we're learning our third gas law. This one is called Gay Lussac's law. And so Gay Lussac's law just says the pressure of a gas is directly proportional to the Kelvin temperature as long as volume is kept constant. Okay. So this one, I didn't shorten up, but we can write something really short. You don't have to have like the formal definition. If something is directly proportional, what does that mean? It's the same. So let's say we increase the temperature, so then it means you also increase the pressure. Okay. So if you want to shorten up the words, directly proportional just means they do the same thing. So if temp goes up, pressure goes up. Okay. That also means like if temp goes down, pressure goes down. Okay. And then you do need to get down the equation. Okay, so the equation for Gay Lussac's law is P1 divided by T1 is equal to P2 divided by T2. Sorry. Okay. All right, so then if you look at this equation, what do you think P1 stands for? Okay, what does the 1 mean?
Pressure 1.
Okay, pressure 1 or initial pressure. What do you think T1 stands for? Okay, so then T1 is initial temp. What unit does temperature have to be in? Okay, if I were you, put a K by your temp, just so you know it has to be in Kelvin. What do you think P2 means?
Pressure 2.
Okay, pressure 2, or that final pressure. And then what does T2 mean? Temp 2, or final temp. All right, we're going to do one practice problem using Charles's law. Okay, so follow along with me up here. The gas left in a used aerosol can is at a pressure of 100 kPa at 27 degrees Celsius. If the can is thrown into a fire, what will the internal pressure of the gas be when its temperature reaches 927 degrees Celsius? All right, so we're going to start this one just like we started the other ones last week. First, you just have to identify what's given to you. Okay, so just start at the beginning of the problem. What's the first number you see? Okay, so 100 kPa is a kilopascal. That unit is a unit for what kind of measurement? Okay, pressure. So kPa is pressure. So we know P1 is 100 kPa. All right, what's the second number you see? Okay, second number is 27 degrees Celsius. Celsius is a unit for? Okay, so T1 is 27 Celsius. Can we be in degrees Celsius? Okay, what unit do you have to convert to? Okay, how do we get from Celsius to Kelvin?
273.
Okay, so what's 27 plus 273? Okay, 300. So I would recommend convert that right off the bat. Remember when we're adding, all three of those are going to be significant, so just put that decimal after. If you don't, it's going to cause some really weird rounding. Okay. All right, what's the third number do you see in the word problem? Okay, 927 degrees Celsius. Again, that's a measurement for temp, right? So T2 is 927. And what do you have to do to convert that to Kelvin? Okay, so what's 927 plus 273? Okay, are you getting 1200? Okay. All right, and then finally, what are you solving for? Okay, so we're solving for that second pressure. So I'm going to put P2 in the question mark. Okay. Don't skip this step. So today we're obviously using Gay Lussac's law since that's the one we're learning. However, the day will come where there's 5 equations and you don't know which equation to use. This is how you'll figure it out. Okay, so then you'd have to look what equation has P1, T1, T2, and P2 in it. Okay. All right, so then that equation is Gay Lussac's law, which is P1 divided by T1 is equal to P2 divided by T2. So now we're just gonna plug in the numbers in that like format. Okay, so P1 is 100. T1 is 300. P2 we're solving for, so I'm just gonna leave it as P2. And then T2 is 1200. Okay, so this one should look pretty similar to Charles's law, which we learned Friday. Do you agree with that? Yeah. Okay, so for those of you who love algebra out there, you can solve for P2 algebraically, okay? However, how many of you don't love algebra out there and you would like to solve this simpler? Okay, do you remember what method are we going to use? Okay, we're just going to cross multiply. So you're going to start with the diagonal that P2 is not in. Okay, so you're going to multiply 100 times 1200. Push equals, get an answer. What's 100 times 1200? 120,000? Okay. Then you divide by the number that's in the diagonal of P2. So divide that by 300. Okay. And then what do you end up getting for P2? 400. Okay, so you end up with 400. And then finally, your unit for P2 has to match P1. So what's our unit? Okay, so it's 400 kPa.